We are recording.
Hello, everyone. Welcome to this AIM Center webinar. My name is Luis Perez from the AIM Center, and it's my pleasure to welcome you to today's webinar. Before we begin, I just want to share with you a few things about our Zoom environment to make your experience a lot better. The first thing is that we do have closed captioning available, and to view those closed captions, make sure you click on the closed caption button in your Zoom controls. The captions will appear along the bottom of the screen, and I want to thank our captioner for today, Shayna, for her services. We also encourage you to participate in the conversation. Some of you were already doing that in the pre-show banter that we had. And we will do that through the text chat. There is a chat panel in Zoom. But make sure when you open up the chat panel that you select all panelists and attendees from the drop-down menu. That way everybody can see your messages and your contributions. Otherwise, only the person that you have selected will see those messages. And also, as you learn new insights, new tips from today's webinar, please share out what you learned on Twitter or your favorite social media using the hashtag AEM, the number 4, and then all. ALL. And if you're just joining us, all of the information that you need for this webinar is available on the event page on the AIM Center website. We've created a short URL for that. I'll read out that URL now. It's bit.ly, bit.ly/math A11Y. And that is case sensitive. For those of you who don't know, A11Y stands for accessibility, because there are 11 letters between the A and the Y. So Leslie is also going to share that link out in the chat. So that will allow you to get the slides. And then when the recording is available, we are recording. When the recording is available, you'll find it on that page as well. All right, with those logistical considerations out of the way, we'll go ahead and get started with the webinar proper. My name is Luis Perez. I'm a technical assistant specialist with the National AIM Center, and today I'm also joined by Lynn McCormack from the AIM Center. So Lynn, can you say a few words?
Sure. I'm Lynn McCormack. I'm a senior technologist on the AIM Center, and I'm kind of a nerd when it comes to math accessibility, so I'm so excited to be here with you today.
Great. And then we have a distinguished panel of presenters today. I'm so excited about all the great information they're going to share. We have with us Paul Brown from Texthelp, Steve Clower from Desmos, and Suan Ma from the Diagram Center. And they'll introduce themselves when we get to their section of the webinar. With that out of the way, we also want to find out a little bit about you. So Leslie, if you can go ahead and launch that poll for us. That would be great. So please let us know using the poll that should show up on your screen now. What is your current role? I'll give you a second, well, not a second, I'll give you a little bit of time, a little bit of think time there. So just let us know what is your role right now. All right, Leslie, if you can go ahead and reveal the results. Let's see who is joining us today. Okay, so definitely looks like assistive technology specialist is in the lead here. So quite a few of you are assistive technology specialists, 41%. Then we have teacher in K-12 at 12%. And then looks like curriculum specialist at 7%. And then a large number of you also indicated other, 28%. So those of you who indicated other, could you go ahead in the chat and just let us know what your role is, if it fits into that other category. I'll go ahead and close the poll, and then we will continue with the webinar. So thank you for your feedback there. All right, so now that we know a little bit about you, I'm going to turn it over to Lynn, who is going to give us a quick overview of MathML.
Super. So what is Math? So we're going to cover what is MathML, and then we're going to talk a little bit about the benefits of MathML for accessibility, and then Luis is going to talk about what MathDAX is. We'll go forward from there. So what is MathML? ML is math markup language. So it's markup language used to display equations and other mathematical expressions, not only on the web, but in any digital format, such as ePub. And it's similar to HTML. So if you're familiar with HTML, it shouldn't be too scary. So it's similar in that way. So here's an example, and this isn't meant to be scary because there are ways to write MathML that you don't have to know it in quite this way. But it's good to understand that underneath there's a structured language that represents each piece of the equation. So the equation is y equals x squared plus 2, but it's represented in a structured way under the covers. And that structure allows for the accessibility tools to be able to interact with that. So before we had a structured language for math, what used to exist is that you would have an equation in an image, and then that image would have the alternate text. And so that can sometimes lead to uneven implementation, partly because alt text implementation isn't always consistent, as well as long descriptions and the implementation of those were uneven. So now we have MathML in that way. We have a much more consistency for math. So that structured text is really important. And as I said, it's better for accessibility than the images. It can be enlarged. And I'm going to put my UDL hat on, not just my accessibility hat on, because I really feel strongly about the fact that math is almost like a foreign language to some learners. And allowing the MathML to be used in equations, it can then be spoken for all learners. Whereas when you use an alt text or a long description, those generally are not available to all users. So maybe you're an English language learner, or maybe you are have dyscalculia or some issues with math. So many different learners will have access to math if you use MathML than if you're using just an image. And so in 2012, a Dear Colleague letter was written by OSERS, the Office of Special Education and Rehabilitative Services, and they asked the publishers who are publishing NIMAS file sets to start using MathML 3. And so they are encouraged, if you are a user of any of the NIMAS files, then you are encouraged to ask for MathML 3. NIMAS is the National Instructional Materials Accessibility Standard. That's a standard XML file structure that can be used to create many specialized formats for low vision or anybody with a print disability. So you can use those to produce Braille books, audiobooks, and so that specialized format is now required to use MathML 2, MathML 3. But we are finding, even up until recently this year, some of the producers were actually still producing with MathML 2 or some weird combination of MathML 3 and MathML 2. So we've remedied that, or hopefully are trying to remedy that, partially through the awareness raising in this call here today, and partially by putting a new exemplar, which is what we have on the next slide. So, and within the last few months, we've put up a new exemplar for file format for how would you actually use MathML within your NIMAS file set, but it's also a good exemplar because it has the appropriate headers for including MathML 3 in structured documents. So it's useful for both of those purposes.
And I'll transition from MathML in sort of a specialized format and NIMAS files to talk a little bit about MathML in web browsers. So one of the issues with MathML is that not all web browsers support it natively. And even those that support it natively don't always display it in the same consistent way. And so one solution that I want to share with you is something called Mathshare. It is a plugin that provides cross-browser support for MathML. You can learn a lot more about Mathshare at mathjack.org, but I just want to highlight a couple of important features that Mathshare enables. And it's really easy to add Mathshare to a website or a web page. Essentially, it's a couple of lines of code that allow you to make a call to this library, and you put those lines of code in the header of the document, and then you can insert your MathML into the body of the document. So once an expression or a web page has had Mathshare enabled, and you can try these examples for yourself by going to the Mathshare page. What you can do is you can right-click on the expression, and then that brings up a contextual menu. And one of my favorite options within that contextual menu is the zoom or the magnification. And you can decide how you want to trigger that zoom. You can hover over the expression, you can click on it once, you can double-click it. You can also require the use of a special key before you trigger that zoom. So that allows you to bring up that expression so that it's much larger, which can really benefit individuals with low vision who need to really be able to zoom into that expression in order to see it better. And what's nice is that as you zoom in on the expression, you don't lose a lot of resolution. So it still maintains a lot of that resolution. Then another option that's available within that contextual menu is the ability to collapse parts of that expression. And as Lynn mentioned, that's helpful for everyone, because sometimes an expression, when you first look at it, it can be intimidating, especially some of the more complex ones. But if you're able to collapse some of it, then you can focus on parts of that expression without getting overwhelmed. So again, just a couple of features that are accessed through that contextual menu when Mathshare has been enabled on a web page that has MathML on it. Now, writing MathML, I think Lynn hinted at this, is not for the faint of heart. But fortunately, there are lots of different tools that allow you to basically enter the expression and then get the MathML code. So this is one, it's one that I've said is out there. It's called MathType by Wiris. And you may be familiar with the MathType name. That's because it used to be part of design science, and now it's been combined with Wiris. So here you can enter the expression using either the controls. I have a screenshot on that shows the interface for MathType. You can enter the expression using the controls, or you can also use handwriting to enter that expression that way. And then when you're done, what you can do is copy and paste from within Wiris, and that gives you the MathML that you can then paste into another program like the text editor. So you can see the actual MathML code behind that expression. So that's one way you can do it. I am now going to actually turn it over to Paul Brown from Texthelp, who's going to tell us a little bit about Equatio. So Paul, take it away.
Thanks, Luis. I actually can, I think I can just jump on here and actually show the slides from my deck. Should I just do that?
Sure, absolutely. Go for it.
There's not a whole lot of, but thanks again for having us on. And I do appreciate, Luis, you using formula, the one that I know, the quadratic formula in your example. Super exciting. So Equatio, can you see the screen okay?
Yep.
Great. So in a few minutes here, I'm just going to show Equatio, kind of give everybody a 10,000-foot view. We're not going to get too detailed, but I want to give you an idea of what we've done with Equatio. I know that there's some folks from higher ed, I think, on here as well as K-12. So to give you an idea of what we've really done, in K-12, we've possible to really insert math into documents. Now that is right now in a couple different formats, and we're actually going down a path looking at MathML more. So I appreciate that explanation there too, Lynn. Reading math aloud, as you said, there's some complex formulas out there. So we've been able to make that possible to read it aloud easily. We have integration with the Google Suite, the G Suite. So we've added math capabilities there. And then the ability to really collaborate in math, which essentially you haven't been able to do easily. All these other areas of the curriculum in K-12, science, social studies, English, people are collaborating, but it's not possible in math, or I should say it hasn't been, and now it definitely is. On the higher ed side of things, something really exciting that we're showing now is the ability to convert math textbooks using our screenshot reader into MathML, which is great. I'll show that. Reading aloud any math for that group is great. Not only do we work inside of Google, but also Microsoft on the desktop, whether you're on a PC or a Mac. And then those instructional design folks that are really trying to get faculty to embrace and engage with students more digitally, we're able to do that. For the higher ed group, to let everyone know, in a couple weeks, February 7th, we're doing a free webinar with Susan Kelmer, who's in disability services at the University of Colorado in Boulder. It's basically showing how to use Equatio to make math accessible in the conversion process. So that's February 7th. If you wanted to sign up for that, I've got the link right here. It's bit.do/FEB, so Feb7. And you can register for it right there. And it should be really, really helpful for those of you who are handling math textbook conversion in the higher ed setting. Susan was the one that kind of tipped us off to some really great, didn't know we were actually doing for accessibility. So now we're on top of it and continuing to develop that as well. I'm going to jump out of this and to give you a quick kind of overview of what Equatio is. If you want to try it, you can try it for 30 days. And the way to do it is you can Google Texthelp in our products page, and you'll see there where it says try now, and you click on that. And it's going to show you 4 different platforms. So if you're on a Windows machine using Microsoft Word, you can download that. If you're on a Mac machine, same thing, using Word, you can download that. If you're using Chrome, this will take you right to the Chrome Web Store. And then there is a web app that kind of hard to show in a situation like this, but you can put basically a tool on your phone, your smart device, and take pictures of math, and we can pop it accessibly into a document, and that's the way you do that. So this is what the would look like. So you'd add it here. Now I have done that. So the first place and first thing to show you with Equatio is how easy it is to access math from a website. Here I've got the Equatio extension installed. So when I'm on a web page, I click on the Equatio extension and here. And for those of you that are familiar with our other product, Read and Write, we have the screenshot reader, which essentially allows me to click a button, gives me some crossovers, and in Read and Write, you pull around some inaccessible text, maybe an image. Here, the idea is finding some math. In this case, I have no idea how to say this equation, but I don't have to worry about it, because what I do now is pull a box around it, and when I let go, you're going to see that it's going to do an OCR scan on that math and then read it aloud to me, and then a couple other things.
Equals the integral from 0 to normal infinity of e raised to the negative st power h of t.
That's exactly how I said it. So if I didn't know how to read it, this is an easy way. So this is great because not only am I getting the math and hearing it, but it's read the way that it should be read. And sometimes when we have human readers, they're not always that savvy with the math, so it takes them a while to figure out exactly how to say it. The other thing is that the research shows when you have a text reader like this as opposed to a human reader, score better. And the reason is because they don't have that sometimes tough interaction with a human where they don't want to ask a teacher to read it again and again, but they need to have it read 4 or 5 times. They can replay this as many times as they want. So this can be done on a website here. This can be, interestingly, if you're using like, here's Khan Academy, and here's something that Khan Academy had up there. So I just paused it. I could also pull a box around Khan Academy.
Open paren 3t plus 4 grams close paren equals 2 times 6.
So now I've made that accessible from this video. The other thing I want to show is the second piece here that let's say that I'm engaged with this math, but I want to actually pop this into a different document and take it extensively. You'll notice that there's a couple options here. It's a little small, sorry about that, but when I choose these buttons, I can either copy the LaTeX or copy the MathML. If I copy the LaTeX, this will take me into the next place that Equatio helps out, and that's inside of a Google Doc or a Word doc. So if I go into a Google Doc here and I click on extension, here it's going to give me Equatio as a toolbar down at the bottom. And here, you'll notice that there's many different methods of input. This one right here, LaTeX, because I can LaTeX from that Khan Academy page, and I paste it in here, so I just do a Control-V. Notice the LaTeX is on the left, but it's created accessible math here on the right, and this is where I can insert that math directly into my document. So what we've done here is taken that math and we've made it an image. And if I look at the alt text here, you can see that that's where the math is. So if I'm using something like a screen reader or a text tool like Read and Write, in this case Read and Write for Google, I can play that math and it'll read it.
Times open paren 3t plus 4 grams close paren equals 2 times 6.
So that's all. That's really good. I mean, that's one way to do the LaTeX, but you don't have to know LaTeX language. I'll show you what we can do with that MathML in a moment. I'm just going to finish the other tools here inside of a Google Doc. You can do speech input, so I could speak my math here. A squared plus B squared equals C squared. I can insert that right there. So really great tool. Actually, that's the original tool that you something called GMath, which is where Equatio was born from that program. So the nice thing about it is anyone that downloads or adds Equatio, all the tools for 30 days, and after 30 days, that tool is free. So if you have a student that is really having some success with that, that's a great tool to use. Another method of input is handwriting. So in this case, I've got a touchscreen computer, but a lot of K-12 teachers, they have, they can get the program for free as K-12 teachers. They'll put it up on their smartboard. Their students come up and use their fingers, and here, I'm going to do 3x plus 4x equals 7. Let's say y, and if I wanted to change that, I could make that something else. Let's say, I don't know, 7e. I don't know. Oh, I don't know what I did there. You can tell I was a social studies and language arts teacher, not a math teacher. But here, it recognizes it, and I pop it in. The beautiful part here is that students could have their Chromebooks or their iPads open to this Google Doc, and they could have just seen that student's handwriting up on the smartboard turn digital here. And then again, I can read that as well, and I can edit it if I wanted to there. So that's another method of input. Another one here that's probably my favorite that I alluded to before, because I can, my favorite formula is the quadratic formula here in what we call the equation editor. If you start to put math in here, it's going to give you some options. In this case, I put QU, and if I want to put in quadratic formula, I just scroll down and click on it. Very similar to like a word prediction for writing. And when I insert that, you'll see it pops that into my document. Or it should have. So I've got that math there in the document, which is really. You can also do some STEM things here, so you can put in like aluminum diacetate, and it gives me the formula for that, and I can pop that in there as well, so that's kind of neat. A couple of the other tools here you'll notice at the bottom, I won't get into this now, but if I did this Equatio mobile, I could snap this QR code with my phone, and it would take me to a site. I log in, I can take pictures of math, and it'll convert it to digital math and pop it into this document. So really, really powerful. There is a component here called Desmos. I'm not going to steal the fire there, but basically you'll get a great demo in a moment here where you can use Desmos, but then easily pop it here into my document. I'll see that if I'm putting in formulas, it's going to give me that prediction capability right inside here, and then I can pop this in there as well. So I'll let the Desmos gentlemen speak to that, because that's a really, really great things with accessibility. We're excited to have it in there. Last couple of things. what I showed you in the Google Doc, you can also do now in Google Forms. So when I'm on a Google form and I am putting in, let's say I'm a teacher that is putting in a formula, you notice I've got Equatio installed, so this button pops up, and now I can actually use Equatio to insert in to this problem. So the nice thing about this is there really has never been a way to insert math into Google Doc for teachers, and now there is. Add that in. The nice thing is if students have Equatio, when they are responding here, they will also see that Equatio button and be able to respond in math. And this has opened up so many doors for teachers when students coming in to do bell work, that sort of thing, to really get a quick idea of what students understand to help guide the instruction, as Google Forms do in so many other subjects and areas. If you're using Google Slides, you can use Equatio to insert math there as well. And then a couple things to show you with Equatio Math Space. And what this is really a place where a teacher can create a math, let's say, worksheet and share it out with students. If I'm an elementary teacher, I can do that here. I can add some shapes. We've just added some art shapes, so things like rulers and proteins, that sort of thing can be added in. And then a teacher can share this out, saying, I want the student to actually respond. And when I do that, I can choose to either use a link, or if I'm using Google Classroom, I can share it through Google Classroom, and then it'll just show up as an assignment for my students there. So there's the options there to share it. Middle school would do some different things with it. High school, college level, this is a Yohaku puzzle where I could have the students finish this. It's kind of like Sudoku, but you got to do a lot of math to do it. So students can do that as well. So that Equatio Math Space, to get to that, anytime you have Equatio open, you can just click down here and it'll give you some options. And one would be to Equatio Math Space. So last couple things to note here. Canvas. If you are using Canvas, Equatio now works inside of that. So if you are creating content, tests, quizzes in Canvas, you'll see the button there. You can use Equatio. If you're a student responding within Canvas, you can use it there as well. So this is what we call an LTI integration. We're hoping to be adding this to more LMSs down the road as well, but Canvas was the first one we did. Last thing, I showed you back on this page, we go back to this. This is at Khan Academy. If you recall, that screenshot reader that you'll notice, it is there in Google Docs as well down here. If I came across math and wanted to read aloud, it's there. But in this case, it was on the site, or this Khan Academy site. When I clicked on this, I did the copy LaTeX and I popped that into the Google Doc as an image. What we can do now is when I copy the MathML, now when I go to a Word document, and it puts that equation in there, but it's in the MathML language. So now, because I've got math type installed and I double click on it, now I can just use math type to change that if I wanted to. But I've taken inaccessible math image and now easily added it into a Microsoft Word document. And this is how a lot of colleges are using Equatio for that math conversion. We're hearing that it saves them anywhere from 50, 60, 70% of the time because they don't have to go in and create the math themselves with MathML. Equatio automatically does it. So we're looking at building this capability out more because we are understanding now how important MathML is in this conversion process. So if you need any help with this, you can find some great videos on our YouTube page. You can go to our website, training.texthelp.com, and there's a free course you can take to learn about Equatio, which is great as well. And if you have any questions, you can fire them off to me. I can help get you set up with the free trial version. We can do pilots. If your school or institution wants to do a webinar, we're very happy to do those as well. You can email me at paul.brown@texthelp.com. That is a really fast version of that demo. Jeez.
Thanks so much, Paul. If you can go ahead and stop sharing your screen. Perfect. Thank you so much for that. Let me go back to my presentation here. All right, so thanks for that overview of Equatio, Paul. Next, we're going to be hearing from Desmos. So give me 1 second here while I advance the slides. All right, so joining us is Stephen Clower from Desmos. So Stephen, take it away.
Start share. This will space.
All right. Can everyone hear me?
Yes, we can, Steve.
All right.
Voiceover muted.
So hello, everyone. My name is Stephen Clower. I am a software developer in charge of accessibility at Desmos. So you might be wondering, what is Desmos? We are a startup based out of San Francisco, and since 2011, our mission has been to create best-in-class tools to help students love learning math. We create free online four-function
has stopped screen share.
Scientific and graphing calculators.
Luis Perez has started screen share.
And apologies for voiceover. I can't seem to mute that through the Zoom client. So you are probably going to hear some of that. So, but anyway, we create various calculators that are used in classrooms all over the world, as well as interactive curriculum that use those calculators as a base. Our tools are used by millions of students every day across the globe. If you want just more general information about us, of course, you can go to Desmos. That's D as in Delta, E S as in Sam, M as in Mike, O S as in Sam.com. So DESMOS.com. So as far as accessibility, we believe very strongly that students of all abilities have the right to use the same tools as their peers. For the past 3 years, we have developed various accessibility features into our software, some of which includes very broad screen reader compatibility, improved color captions, graph sonification, which I will be demonstrating here in just a moment, support for Braille input and output. So if you have a refreshable Braille display, you can actually read and write math in Nemeth or UEB, as well as the ability to generate graphs suitable for sending to Braille embossers. We have all of the nitty-gritty details on our accessibility page. These also include screen reader setup instructions, things like that, at desmos.com/accessibility. So as far as graph sonification, sonification just means basically turning the visual representation of a graph that you can see into something that a student can hear and get roughly the same idea. So I'm going to
Voiceover that a student can hear and get start share.
Start sharing my screen
continue,
here.
cancel, continue, default button. Select a window or an app. Sharing screen list box. Collection in desktop, whiteboard, iPhone / mail, desktop, mail, Safari, Desmos vertical line graphing. You have started screen share. Your screen sharing is paused. Zoom ID Safari 952050804. Voiceover muted.
Okay. Are you able to see my screen?
Yes, we can. It looks great.
All right. Beautiful. So the first thing I'm going to do is just type a very simple equation
Voiceover on
of
greater
y
than
equals
beautiful.
x.
The first thing I'm going to do is just
Well, if I can get into
Zoom Safari. Type in very simple equation.
in one moment. It looks like my voiceover is not reading
Voiceover
Safari.
VMware Safari. 1 moment. It looks like my voiceover. Voiceover speaking. Safari. Wait, Zoom. Leave meeting system dialog. Zoom. Safari. VMware Safari.
Okay. Well, it looks like Safari is not cooperating here, unfortunately.
Greater than Steve Clower. Oh,
So let me see if I can get it
well,
to
looks like
come
Safari
back
is
up.
not. Authentication. Cooperating here. Quit application table. If an app doesn't respond, you can open this window. Table. Safari. You force quit. Default. But in dialog. So let me see if I can get it to Safari. Voiceover speaking. Zoom. Safari. VMware Safari.
Well, that is very unfortunate. I apologize. I was going to demonstrate our various graph sonification functions.
Well, that is,
But
I
it looks
apologize.
like I
John, voiceover muted.
will not be able to do that at the moment with Safari and Zoom. But we will go ahead and continue. I can at least describe roughly how our current system works. So if you take a simple equation like y equals x, what you'll see on the screen is a line that goes from left to right, bottom to top. And if you were to go into our audio trace mode, which is what we call this particular feature with Alt-T, you can then explore the graph using your arrow keys to move across the curve. So left will move you to the left, right will move you to the right. Tab and Shift tab will move you between any points of interest that might be on that line. If you were to hit the letter H at that point, what you would hear going again from left to right is a tone ascending in pitch. So it will go, and that will give you an idea of what the graph looks like on screen. And of course, if you were to do something like y equals minus x instead, the tone would go down. So mew. If you were to do something a bit more interesting like y equals sine of x, again, you'll see the sine wave appear on the screen. And going from left to right, you'll have the graph and the tone that you hear will go up and down. So it'll go mew. So again, it gives you an idea of what the graph looks like, even if you can't necessarily see it. And we've got a few audio cues that we use as well to sort of help you orient to what may be happening on the screen. So whenever the y value is less than 0, you might hear some static. If the x value is less than 0, the sound of the tone is actually a little different than it would otherwise be. And also if the line intersects another line, you'll hear a brief pop sound to indicate where that's happening. So students do have a pretty easy way to explore graphs, but we also recognize that either the playback speed might be too fast or too slow, so you can adjust that. We have hotkeys for that, Alt-1 through 5, Alt-1 being really slow, Alt-5 being very fast. So anytime you hit H, it will play and adjust its speed accordingly. We also know that not all graphs are easily interpreted strictly through sound. If you were to take something like x squared plus y squared equals 25, for example, that gives you what looks like a circle. If you were to play that through audio trace, what we do right now is we play both solutions separately. So you'll hear the top half of the circle followed by the bottom half. This is something that's a lot easier to understand if you send it to a Braille embosser so that a student can actually feel it. And I'm very happy to be able to say that this is something that we can do today. Simply go to the share menu or the little wrench icon on the right, choose export, and under the size options, you'll see different Braille embosser options. So the Tiger VP Max, as well as the enabling technologies Romeo and Juliet. So you simply select the embosser you want, download the image, send to the embosser, and what comes out is a graph that the student can read in Braille. And any sort of labels and such are also turned into Braille as well. So we're always looking to improve our tools. If you have any comments, we definitely welcome them. You can send those to accessibility@desmos.com. And I will go ahead and turn my audio off and send it back to Luis.
Voiceover unmuted.
Thanks so much, Steve.
If you could, I think you're still sharing the screen, Steve, so if you could stop that share. There we go.
Perfect.
And There have been some questions coming through the chat. I see some, Paul and Steve, feel free to answer some of those questions. I just want to let you know, if we don't get to all of your questions in the chat, I'm going to go back over the transcript, and then we're going to post the answers to some of those questions in our the same page where you registered for this webinar, and also where you'll find the recording and other resources. All right, so next we're going to be hearing from Suan Ma from the Diagram Center, and she's going to talk to us about an inclusive editor for solving math problems. So Suan, take it away, and I'll be advancing the slides, so just let me know when to go to the next one.
Great, will do. So again, can everyone hear me okay, actually?
Yes, we can.
Okay,
great.
So I just wanted to kind of introduce myself. I'm Suan Ma and representing Diagram Center at Benetech. And if you can go to the next slide, please. Many of you might heard of Benetech through our sister program, Bookshare, which is a Department of Education funded project as well, or OSEP project as well. Diagram is the same, and what we focus on in the next slide is more about how do we make STEM more inclusive and accessible for all learners. So different from a couple of my fellow presenters, this tool that I'm going to be sharing today with all of you is related to math, but it's much newer. So it's only been in inception since about 1.5 years ago. And what we're, as I mentioned, what we're trying to do is really make the process of working through math for students who are learning it and struggling with it, kind of trying to distill it down and figure out how we can make that easier. And so the Diagram Center, in addition to working on various tools, such as what I'll be sharing with you today, Mathshare, we also work on lots of things related to standards that further MathML, as well as best practices, working with different publishers and content producers to really further the entire ecosystem. And on the next slide, so what we're going to be talking about today is, I'm just going to kind of start at a higher level where students struggle with math and how we started on this project that we began. And really what we were looking, we went into a few classrooms, and these are students with various disabilities again, and we found that students had a lot of difficulty working through math because sometimes they struggled with organization. Other students had difficulty reading students' handwriting, or students themselves sometimes had difficulty writing legibly. And of course, a lot of times when you're learning math for the first time, let's say you make a mistake. When you're working through it in a lot of the traditional forms available today, you erase one thing and essentially you forget your entire train of thought a lot of times and have to start from scratch. So whether you're working on pencil, paper, or some digital form, we were trying to say, well, how do we look at ways to support the practice or solving process a little bit better? And then, of course, you know, a lot of teachers and educators, as you all know, will ask students to say, okay, are you showing your work? And that takes a lot of time, and it's very difficult for certain students who are already struggling with accessibility to organize or write legibly, to really document that work and then demonstrate what it was that they did for the teacher. So this was kind of the problem that we were trying to address when we started this particular tool. And on the next slide, and you'll see that when you dive into, what we found is after you dive into some of these complexities of why it's so difficult for students with disabilities to work with math, it's because there's so many different components going on. And on this page, on this slide, you'll see just one example that has maybe 10 to a dozen different steps solving one problem. And there's so many elements involved in it. You have to be able to see it. You have to be able to write or type, which oftentimes require very fine visual motor skills. A lot of times you also need to be able to transfer this to symbolic language. So as Lynn mentioned, you know, math is a foreign language for certain people. You're learning it, and it's not something that you just know intuitively. You have to learn it and pick it up, and transferring it even from word problems or from pictures to symbology, there's that difficulty there. And then there's a lot of limited options in terms of how you can both enter the math as you're solving it, as well as hear it. And then if we get to additionally cognitive processing, there's various organization skills. You have to have focused attention for a certain amount of time to actually be able to work through the entire problem. You have to have working memory. And it has to be able to process quickly enough so that you can work through a whole problem. And then on top of that, you also have to understand the core math concepts. So if you imagine all of these things needing to happen together and compounded on top of each other, this is what, some of the things that we discovered was so difficult about why math is challenging for students, and particularly students with disabilities. So on the next slide, Luis, actually, I'm going to just keep going and take over the screen share, if that's okay, and do a live demo. And okay, so let me do that. So I'm just going to walk through one problem today. And as I mentioned, this is a very early stage project. This is something that we're still developing and continuing to. So if anybody is interested in helping us work through and continue to improve the tool, please feel free to reach out to me. We definitely welcome, especially educators and people working directly with students with different needs. How do we make this more inclusive and accessible for everyone? So on this page, the idea here, this is still kind of a prototype that we're continuing to develop. It's a bunch of algebraic problems that we pulled out of a 7th grade math book. And I'm just going to go through one example today and demonstrate how it works. And so let's just take this number 6 problem, which is 7x minus 13 equals 1. And as you can see on this page, when I click on a problem, we're trying to isolate just a single problem. So, a lot of students, perhaps they get a little bit overwhelmed when there's so many problems on a single page. What we're trying to do is first extract a single problem. And here, 7x minus 13 equals 1, the idea is how do we make the explanation of the work and that process available both for the student to refer to and check their work before submitting, but also more informative for the teacher. So if a student does go wrong, there's more information to help diagnose and evaluate the challenges. So if we were to say 7x minus 13 equals 1, one of the first things that I might do is recognize that I need to add 13 to both sides of the equation. So I'm just going to, on my keyboard, and hopefully this sound isn't going to be too disruptive, add shift plus on my keyboard, and I'm going to type the numbers 1, 3 directly on my keyboard, and the same thing on the right side. And then after that, you'll notice that there's actually a bunch of symbols underneath this palette that I just used. We have started, or we've continually trying to improve the accessibility, but one of the first things that we did was add labels on top of all the symbols. So you'll see, for example, the dot has a dot times label as well as a quick key function. So as you're tabbing through it using a screen reader, you can also hear and select the different options. For students using switch devices or maybe a laser pointer, you can also use that. With the idea is there's lots of things that we are trying to include and make accessible for everyone. And so one of the symbols that I'm going to use is actually sort of under the edit function, which there are a few things that we've introduced. The one that I'll be using now is a crossout function. So essentially what I do is I use my keyboard, and I can either use shift and arrow left and right, or I can highlight, which I just did, the 1 and the 13. And there's a slight calculate button on the bottom that I can apply. And this automatically calculates the right side of the equation for me and simplifies it. The idea here is you can only apply it to simple calculations, because at this point with algebra, the idea is not to teach students how to do operations like addition, but to make it easier. So as they're starting to introduce things like statistics, it helps to have access, and realistically you would have access to a calculator. On the left side of the equation, this time I'm going to use my keyboard. I'm going to press shift and arrow to the left to select negative 13 plus 13. And essentially, I'm going to use the crossout function. And what that does is it puts a blue X over the negative 13 and 13. Now, if I try to just simply add a step, you'll get a warning saying, please describe what you wrote. And this is something that educators really appreciate, because they oftentimes try to get students to do this, but if you're forced to do it, with a computer system, then it actually does happen. Otherwise, it's a lot of work to try to remember to remind your students to all do this. So here it's basically, you can do a brief type description, or you can use the microphone to dictate a description of the action that you just provided. So I'm just going to type it this time in case there's something wrong with the audio with my headset and such. So what I did here is I added 13 to both sides to isolate the x's from the numbers. So that's, you can type whatever it is that you want. Now when you add step, you notice that in the history section, which is above the active editor, you'll now see that the markings and the work that I just completed is noted and recorded there. But what happens is when you add step, it cleans up all of that excess crossouts and calculations for you. So here, you'll now see that it's left with 7x equals 14. So I removed all of the prior work. And then as you continue on, I might say, okay, the next thing I'm going to do thereafter is, in this case, I'll use the divide symbol, divide by 7. And maybe on the right side, I might use a fraction symbol. So again, some of these is getting familiar with the keys, but fraction, and then I might type 7 there. And then again, the calculator function can be applied when I select the 14 divided by 7, it automatically changes to 2 for me. And then on the left side, I might say, okay, the 7s cancel out. There's a cross out and replace function in this case that I'm going to use, and I'm just simply going to replace that with an x. And this time I'll type and say divide by 7, then simplify to reach final answer. So add a step, and then there you go. Your final answer is now 2, and it's all cleaned up. There's also ability if you decide that as you're reviewing this work as a student, maybe you made a mistake in the middle, you actually do have the ability to go back and edit any step. So for example, if I had accidentally typed this as 14, but I meant to type 15, I could go back and do that. And then it would update the simplification under just step 2 for you. Or I can go back again and change it back to the correct answer, which was 14. So update step. So that allows students to say, okay, if I made a mistake in the middle, I can actually go back and revise it, not having to erase everything and start from scratch. So that's sort of the idea of Mathshare. Again, it's a very early stage product. The screen reader support is there for limited screen readers, but we're continuing to try to improve upon it. And one of the things that would be really helpful is if you are an educator that works a lot with students, one of the things that we're exploring is that recognizing that, for example, crossouts, you know, a blue crossout isn't really helpful for someone who cannot see it. So we recognize that for different audiences, the usability, while the tool is accessible, the usability actually needs to be continued to be improved. So if you are a student or a learner with different preferences, you might not want the crossout and the copy down function. You might want to just be able to have access to the history and the steps, but have a clean slate to start from. So there's different kind of experiences that we're continuing to explore. And so if you do have input around that, that's definitely welcome. You'll also notice that, again, the symbology that we started with is just algebra to start because, you know, again, this is a very new tool. We started kind of testing at the end of last year. There is the capability to expand the symbology and the operations to include a lot more math disciplines. But for now, because we're still trying to understand the different interactions that a student might need, this is what we're starting with. We've also started to explore things like actually including a sketch pad that if you're working through different types of content like geometry, it would also allow you to interact with an image that an educator or student would be working with. So lots of different things that we're continuing to build upon. And then the way that it interacts right now, so you can definitely save it and then share your work with others and come back and revisit it. Or if you go back, let's say, to a home page, we also have just in recent months added the ability for educators to create their custom sets of problem sets here. So there's also, you know, you can create a new problem set, you can edit this existing one, and then share that with your students. So I'm going to stop share and go back to Lewis.
All right, give me 1 second while I bring
Okay.
up again. Try that again. It should be seeing my slides now.
Yeah.
Yep. Those are the slides. Confused me because
these are just the slides in case. I wasn't sure about my internet connection, so I just wanted to include them in case we needed them. So again, if you have any questions or if you're keen to help us keep developing at this tool, you know, there's definitely lots of different features that we're still looking to build out. It's very much still a work in progress. Please feel free to reach out, and we welcome all input.
Great. Thanks so much for that presentation, Suan. The 3 presenters today make me want to go back to school and take math again. I really wish I had all these tools when I was taking my math courses. So we've looked at a range of tools today. We've looked at Equatio from Texthelp and the support for text-to-speech, the ability to input math in a variety of different ways with handwriting, with typing, with your voice, be able to get the LaTeX and the MathML for use in a variety of different places. We then, Stephen walked us through sonification and the way that we can use that to make graphs more accessible to individuals who need additional audio support with the use of pops and different sound effects and so on, as well as the ability to export out to, these tactile graphics. And then finally, Suan just gave us a great overview of a really great tool that will make it easy to teach math with Mathshare. So we have a few minutes left, so I'm going to open it up in the chat. Any questions that you still have for our presenters, our 3 excellent presenters? I want to thank them so much for joining us today, and we'll see if, Lynn, if you can help me with the chat, see if there's a few questions that we can address for any of our presenters again.
Yeah.
As you do that, I just want to remind you, we're always looking for feedback, trying to improve these webinars. So we have a survey, and Leslie is also going to pop that link into the chat. This is a SurveyMonkey survey, so we'd appreciate your feedback. That really help us continue to improve these webinars and offer helpful information for you all.
And so just for that survey, one of the things I know that we were thinking about is perhaps doing a more in-depth on MathML, writing MathML, tips for doing MathML, best practices, because there's some great resources out there, but it's scary. So we didn't want to do that without asking you all if that's something that you're interested in. And so if it is, please do include that in the survey if you're looking for kind of a next round. We gave you a really broad view of a variety of different tools, lots of things to think about, but if you are actually creating MathML, we are happy to give you some support in that effort as well. So there was a question here about regionalization of math speech. So I'm not familiar with regionalization of that. It may be that the tools used in different parts of the country happen to have a different way of interpreting that, but I'm not, I don't. And it could be that those regions actually use that same tool, and that's why it ends up being regional. But yeah, that is not something that I've been.
That's a question we can do a little bit of research
on that
and post the answer to the event page where you'll find a recording for this webinar as well. Also want to make sure you have the contact information for all of the presenters today. So there's Lynn and myself at CAST and the AIM Center. And then we have Paul, Steve, and Suan, who are wonderful presenters that joined us today. So let's see, we have, I think, 2 minutes. So for any outstanding questions, please share them in the chat and we'll try to answer them. But again, we'll go back through the transcript for the presentation today, and we will, any questions that are outstanding that we think would be helpful for everyone to kind of take a peek at, we will try to do some research on them and post them on the AIM Center event page for this webinar.
Great. Thank you all.
Otherwise, If there are no further questions, I think I saw one pop up in the chat. Please join me in thanking our presenters, and I hope you're all safe and sound and warm wherever you are, and we will see you on another AIM Center webinar real soon.
Or at ACIA next week in sunny Florida.
Or at ACIA in sunny Florida, so make sure to look for the AIM Center and CAP. We'll be there in force, so we look forward to connecting with you.
Great. Hey, looks like a lot of our friends are going to be at ACIA in sunny Florida.
All right, well, take care, everybody, and we'll see you soon.